Hello, I'm going to present you the Young basics today, and at the end of this video you'll know a little bit why you use Young and how a Young file looks like. So let's start with an example. Such an example could be to configure a network device and to make sure that a particular interface is always up. So let's assume you want to do that. First thing, you'll need to get the information from the device. In order to do that, there are several methods, we'll discuss them, and then you'll get your information, your software will decide whether the interface should be up or not. So in that case, if it's done, then we should set it to up. So you will need to set the interface up and have a feedback loop like this. So this is a basic network programmability case. Let's assume you want to do it on a, let's say, Huawei network, on a Huawei router. Then you will need to send this command and you will need to parse the result, writing a regex. And then your software will have the information. And the next step would be to send the information to the device back in case you need to set it up. So you need to know yet another command to set the interface up. Okay, so now you've done it for one device, and assume you have another one. Well, for instance, a Linux device. Then what you need to do is find yet another command, write another regex, and write yet another command to set the interface up. So basically you need to redo a significant part of the work. So the issue with that is that you're focusing here a lot on the way to get the information and not that much on the automation software itself. So Yang tries to solve that by proposing a way to describe the data. So for instance, here in the IETF interfaces module, we describe the data that correspond to the interface. In that case, the status of the interface is a particular node in the module, a leaf that we call, and it's a Boolean value. And you can get that Boolean value by asking via netconf, which is like polling, or you can stream it via MDT and get regular updates, or even updates only when it changes, which is event-driven telemetry of this data. So you don't have to worry about getting the information, because then you know it's a Boolean, you don't have to think about the format and parse it. And you can also use it to set the interface status, so you can say I want to enable the interface. So basically here we are documenting the API on how to read and write data to the device. This is what Yang is basically. And the nice thing about that is that if you want to get the documentation, you just need to get the file that describes this, which is the Yang file, and you can get them from the device. But with the CLI, you will need to go into the manual and look at all the information that you need. So this is another advantage of Yang. So as I said, Yang is a language for model data. So you have some protocols like netconf that support then based on the data described in the Yang files, setting and getting the values described in these files. And we also have RPCs that we can describe in Yang for operations that are more complex than just getting or setting data. So there are several types of Yang models. The first type is the network element model. This is the one that is in a network element and that you can use to interact with that network element. There are standard models like IETF or OpenConfig models. So IETF models are made by people from the IETF. So they represent basically what a consortium of experts on the subject thinks should be part of the configuration of an interface. And OpenConfig is the same thing made by expert users, notably Google. So in these models, you have the generic options that are true for any kind of network interface, but usually you don't have all the details or all the information you could get or set for these devices. For that, you need to use native models that are specific to a vendors and sometimes even to a kind of device, and that enables you to have all the details about the device. And there is another kind of model, of Yang model, a broad category, which is the service model. A service model is an abstraction of what you have in a service. For instance, if you have a tunnel, usually you don't want to go into the low-level details of the configuration of the tunnel. You just want to say, I want a tunnel from here to here. So basically this is what you will say in your service model, and then you'll have a piece of software, the network orchestrator, which will understand this model and map it to the Yang models of the network element in order to configure it. So this is exactly what AOC is doing. So AOC has a use of Yang that is very intensive. There is the northbound interface. So basically, this is the interface that you use to configure and add new services, and this is in Yang. And this is actually something that you can extend because you can write a new service for AOC. So you will write a service model, and then you can use this service model to instantiate new services. Of course, it does not work just with the service model. You also need some mapping code to map the service model definition to the Yang models of the devices. So in the tunnel case, you would have the high-level option, and then you know that for this kind of device, you need to use this Yang model, and you need to write this value in order to implement your tunnel. If the device does not support netconf, we still use Yang, but it's a Yang model that is actually used to represent the interaction with the CLI. So inside the AOC, it's mainly Yang to Yang mapping, and then there is, if needed, the mapping from Yang to CLI in order to configure the device. So the characteristic of Yang is modular. So once you have written something in Yang, you can reuse it. You can reuse stuff from other models because you can import other models, and you can also augment other models. It means that, for instance, if you are working on a routing, there is a command model for routing, and if you want to have some information that are specific to ISIS, you can say, I want to add this information, you describe what you want to add, and you say, I want to augment the model for routing with this ISIS specific information. Also, Yang has a tree structure, so this structure makes it easy to understand what is inside the model, and it's normalized. So you can use it to visualize quickly what you have in one Yang module or a set of Yang modules with augments and so on. So in a Yang file there is a header that there are some imports, there are some definitions of type, then there is the modeling of the data, there is the modeling of the RPC, and if needed, the augment declaration to say where you want to put the data if it's in another model. So let's dive into this. For the header, there is the name at the beginning of the module, so the name must be a good name that represents what the module does. Then there is a namespace that must be unique, globally unique, to uniquely identify the model. Then there are some various information about the model, like the authors, the contact information, and so on. And there is also, very importantly, the description, because this is what the people that will use the model will use in order to understand what the model is doing. So finally, there is also the import in this part, where you can import other modules from you. So now let's look at how we define the data. And to define the data, we first need to have data types. So the basic types are the ones that we find everywhere, and we can extend them if we want with by adding new type defs that we can put in our model if we need some special kind of model. Then in order to actually store data, we need to have leaves. So a leaf represents a node that will contain the data. It has a name, it has a type, it has a description. So this is pretty basic. And then there are some more options. So for instance, it can be mandatory or not. The one option that is very interesting for Yang is the config. So the config option indicates whether it's a node that you can write or not. So for instance, the CPU temperature, which is the second example here, is something that is measured by the device. You cannot set the CPU temperature, so it's config false. But the host name is something that you can change for a device, so it's config true, and you can use this to write the new name of the configuration. Here is the example of data that is serialized. So for instance, it can be in XML or in JSON. In XML you just use the name of the leaf as the tag, and in JSON it's the key in a dictionary that will map to the value. A container can contain several leaves or other containers, so basically it's a node that will group other nodes. In this case we have a hierarchy, we have the systems that contain services that contain SSH, and SSH is a service that can be enabled and for which we can get the number of active connections. So this is basically what the model on the left is saying, and this is how you would represent it. So basically in XML we are following the tree structure of the Yang module, and in JSON we're using again the name of the container as key that will map to objects representing the container themselves. You can also represent lists in Yang. So a list is a set of containers basically. So a list will contain other containers or other lists, and the element that is inside the list can be repeated several times, of course 0 or more times. The important part of a list declaration is the key. So the key is the part that is used to identify an element of the list. For instance, here it's the name. It means that you cannot have two elements that have the same name. They must have a different name. And here there is even a unique directive that says that you cannot have two elements that have the same IP and the same port. So a leaf, an example of list serialized in XML is just taking the name of the list as the tag and repeating this several times, and in JSON you will map the name of the list to a JSON list that contains several serialization of what's inside the list, which is like a container. Finally, we have the leaf list. So the leaf list is like a list but containing only values, so single values. And for that we can simply repeat the name of the list with the value directly inside in XML, or in JSON we map the name of the leaf list to a list of values. There are some options for list and so on. So that's basically how you can describe the data in Yang. So using this you can build data representation. You can, if you want more information, you can go to the RFCs that define Yang and the encodings and the data model. And I hope that you have enjoyed this presentation. Thank you for watching and goodbye.